Okay, here are the beginning of your gas law notes. The first gas law that we'll talk about is called Boyles Law. It relates only pressure and volume. And in order to use this gas law, temperature has to be constant. And it's okay to just assume that the temperature is constant, even if the problem doesn't state it. The only way you would know you couldn't use Boyle's law is if it says directly in the problem that the temperature does change, or you can see that the temperature is changing. So Robert Boyle discovered that doubling the pressure of a sample of gas at a constant temperature, remember it does need to be a constant temperature, reduces its volume by 1/2. Okay, and this is explained by the kinetic molecular theory. All of this page is good notes for you to have. Because you do need to make sure that you understand that the pressure of a gas is caused by those moving molecules hitting the container walls. That increases pressure. If they have less room to move, the pressure goes up. Okay, so if the volume is decreased, that means its container, the size of it is decreased, more collisions will happen, and the pressure goes up. Okay. These have not been working because of our Adobe Flash Player, but it looks like this one may. So here we go. All this is showing is these particles hitting the container walls. And if we were to decrease this space right here, they would hit the wall harder. So that's what's happening here. The space is decreasing. You can see it's making it have more and more collisions, and that increases pressure. Here is the XY curve for Boyle's law. You will probably see this all the time. So pressure, volume on the Y, pressure on the X, and it does that trend that I put on the board a few days ago. This is the official definition of Boyle's law. You will also have this in your vocab, so you can write it in your notes. I would at least label this Boyle's law and label an X and Y and the trend that Boyle's law, pressure and volume makes, because you will see that graph again. Okay, this is the equation that we are going to use, P1 V1 equals P2 V2. So it's an initial pressure, a final pressure, and an initial volume, and a final volume. Here is what's important. Whenever you use this formula, you have to make sure that your units are the same. So pressure units have to be the same, volume units have to be the same. It's okay if volume is in milliliters or liters, as long as it's the same on both sides. Same thing with pressure. It doesn't matter which unit of pressure you're using, but it does have to be the same on both sides. Oh, that one's not going to work. Okay. Instead of doing this one, I'm going to make it easier on me. We're going to do a couple on the paint tablet so that I can more easily show you these examples. So remember, Boyle's law is going to be PV equals PV. Okay, 1, 1, 2, 2. I want you to go through the same process every time with these, not only Boyle's law, but the ones we're going to introduce in the future. I want you to list your givens for every problem. So for this problem, we haven't even read it yet, but I'm going to go ahead, P1, V1, P2, and V2. I'm going to list my givens with their units right here. All right. So as I read my problem, it says a sample of oxygen gas occupies a volume of 250 milliliters at 740, and I know this got cut off, but it's millimeters of mercury. And it's asking what will the volume occupy at, so here's our second condition, 800 torr. So here I'm going to put my second condition, and it doesn't matter if you do it in this order, okay? You could have put those other ones first if you were sure those were the initial conditions, okay? So 800 torr. My initial pressure was 740 millimeters of mercury, and my initial volume was 250 milliliters. That means I am looking for what will the volume occupy, so the second volume. I want you to list your givens every time. I have to be able to follow your work to give you partial credit, okay? Just simple answers are not going to cut it. You got to show your work. So then plug them into this equation. P1, oh, sorry, I jumped ahead. You need to check your units, okay? And the reason I jumped ahead is because I immediately realized that torr and mmHg are the same thing. So no real conversion is necessary. You can simply change one because remember, mmHg and torr are the same thing. They're both 760. So in this case, I will just simply change torr to mmHg or vice versa. Listen, if you had just changed this one to torr, that would be the same thing because they're the same. If they had not been the same, you would have needed to have went off to the side and done a little conversion, and it doesn't matter which one you pick. You put one into the other. As long as they're the same, you're good. Okay? All right, so P1 is 740. V1 is 250. P2 is 800. And V2 is what we do not know, so I'll just rewrite it. Okay, basic algebra problem. Okay, to solve for V, it's being multiplied here. You do the opposite, so just divide it over. Basic algebra. Just remember though, when you're doing this math, make sure that you multiply those top two numbers first, 740 times 250. And although I wouldn't normally do this, I will go ahead and write this out here so that if you're working this and have questions, you can follow my math. So that is simply these two multiplied together is this number. And then we still have our 800 to be divided. So then I'll hit divided by 800. And the answer, now sig figs are tricky here. Looks like we have one sig fig. So the answer is actually 231.25, but we would need to round this to 200, and the units would be milliliters because that's what was on the other side. Okay, we were looking for volume, so 200 milliliters. Okay, all right, I'll do one more. List your givens. I want them every time, okay? I want your givens every time. Okay, so a 2-liter container has a pressure of this, decreasing it to that so I can see that these are going to be the initial conditions. So I'm going to put 2.0 liters here and 3.20 ATM here, okay? What volume? So we're looking for volume again. Decrease the pressure to 782 mmHg. All right, so this time our pressures are different. They will need to be converted. It does not matter which one you pick. I usually put mine in ATM just because it seems to be the numbers are smaller and it's easier to work with. So what I'm going to do, I'm going to convert 782 millimeters of mercury, real quick here, into ATM. This is what we did yesterday. So you guys had practice. I'm getting a little sloppy. I'm trying not to. Okay. Let me go ahead and do that math. Um, 1.03. Be good. Okay. Now I will use this equation. I didn't rewrite it, but you should every time. P1 V1 equals P2 V2. And let me plug these in. So for P1, I've got 3.20 ATM. For V1, I've got 2 equals P2 is 1.03. Solving for V2. Basic algebra, divided over, show me your work. Okay. Show me your work. 3.2 times 2, 6.4. That's just these two multiplied. I'm only doing this so that you can follow my work if you need to. Still needs to be divided by 1.03. It's okay if you do not do this step right here and just put it in your calculator because I'm doing it just for your benefit. So it's okay if you don't do that. 6.2, wait, what's our sig fig? 2 sig figs. So 6.2, we'll stop there because it's 2, 1. So it'd round to 2. All right, if you're doing that on your calculator, you can see that. The units are going to be liters because there were liters here. So it would have to be the same down here that you were looking for. It'd have to be liters. Okay.